list, right? And a series describes or is involved with a sum, right? So let's read the first question together. And you tell me, do you think, this is the paper I just gave you, do you think this is an arithmetic or a geometric situation?
Arithmetic.
It is an arithmetic situation. So we've got 3, 5, 7, and so on. All right. It's arithmetic. So you already got it narrowed down. Remember, I'm going to give you the formulas. You don't have to have them memorized, but you've got it narrowed down to either this one or this one. These are the two arithmetic formulas, right? Okay. Now, what's the situation? Do I want a term or a sum in problem number 1? Riley? I want a term. And which term do I want? The 21st. How do we know we want the 21st term? It says 3 weeks. Right. So the 21st term will be what?
3 2
So the answer, I can do that without a calculator, the answer would be 43? Easy enough?
Yeah.
All right, number 2, okay, now this one isn't really a word problem. This one just flat out tells you I have a geometric sequence. Okay, so I know the formula I'm going to use is this one. That's the geometric sequence formula. Again, I'll give you the formula, but I'm not going to tell you which one it is. You're going to have to know that's the geometric sequence formula. Now it says that the 6th term is 160.
So the 160 and raise that.
160 goes here. Exactly. That's the faraway term that you're finding. Just like here, it was 43. This is the term that's at the end of the sequence. I think they gave me the first term too, didn't they?
Yeah.
They told me that was 5. They did not give me the ratio, but what's n? 6. So n minus 1 would be 5. How do we solve that? Divide by 5. That's going to be step 1. Is that 32? Oh, that's nice. Because then the ratio is the 5th root of 32, which is 2. All right, read number 3. Tell me, answer our questions. Arithmetic or geometric? And term or sum? So arithmetic or geometric? Geometric. We've got 6, 18, 54. Term or sum? Sum. Oh, I don't know about that. I don't know about that. Let me read that again. If he continues this pattern, how much will he save on the 12th day? Now wait a minute. If I wanted the sum, what would it say? How much will he have saved, or how much will he save altogether, or something like that. This is how much on the 12th day is he putting in his piggy bank. So that would be the 12th term, and it's geometric, so I'm going to use that formula. So 6 times 3 to the 11th, I don't know what that is, but it's going to be a big giant number. Do remember when you answer that question, though, with that big giant number, that it will be cents. And so ideally, I mean, when we have more than 99 cents, which this is going to be way more than 99 cents. When we have more than 99 cents, we don't usually answer in cents. We normally convert it to dollars. So you're going to want to convert that answer to dollars. So does anybody have the answer here in cents? What's it come out to be in cents? Robert, just Robert's talking. What is it, Robert?
1,062,882.
1,062,882 cents. Okay, now if I want to convert that to dollars, what do I have to do? Divide it by 100, or in other words, just put the decimal point right there. So what is that? $10,628.82 cents. Is that right? All right. Is 2009 a term of this sequence? Okay, now wait a minute. What kind of sequence is that?
Arithmetic.
Arithmetic. So that's this formula, right? Now what I want to know is, I'm going to use that formula right there. And what I want to know is, if I kept this list going, -3, 1, 5, 9, da 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 da, would 2009 eventually be a term in that list? Well, if it is, won't it have to fit in this formula? So where will I put the 2009? Right here. So I'm going to say 2009 equals what? -3 plus 4 times n minus 1. Isn't that the question? I don't know what n is. Now, that equation is always going to be solvable. How will you know whether this is a yes or a no? You're always going to get an answer. You're always going to be able to solve that.
It's divisible into n.
Well, what kind of number does n have to be? A whole number, because what does n stand for? The number of terms. When we say a sub 6, that means the 6th term, right? Can we have a sub 5.5? No. So you're going to know whether this is a yes or a no when you solve it. N has to turn out to be a whole number. So go ahead and solve it and tell me if you get a whole number. If you get a whole number, then the answer is yes. And then you ought to be able to tell me what n is. Did it come out to be a whole number? What did n turn out to be?
52.
What was it?
52.
52? No? 504?
I'm close to the term.
Check your arithmetic. I got 2 people with 504, so I'm going to go with 504. Kids, this is this is not even first year algebra. This is like 7th grade. Come on, add 3, divide by 4, add 1. There you go, you got it. So is 504 the answer?
Yeah.
So what does that mean? That means yes, it's a term. It is the 504th term. A sub 504 is 2009. Okay, number 1 on the next. Just let's keep rolling through them. Then we'll only have really one more thing to talk about in this section. We'll be ready to quiz over it. Number 1, Katie found 3 problems in the hallway. Brown found 7. James found 11. If this pattern continues, how many problems will the 29th student in our class find?
So that's a series.
So let's see. First of all, arithmetic or geometric? Okay. Now, we're either going to be looking for A sub 29 or S sub 29, right? We're involved 29 kids. Which one is it? Okay, we've got to read the question, guys. If the pattern continues, how many problems will the 29th student in our class find? What is this number? That's how many problems the first kid found. That's how many problems the second kid found. So isn't this number going to be the number of problems the 29th kid found? What would it say if I wanted to add them up? How many problems altogether? How many problems total? By the time we get to the 29th kid, how many problems have been found? You have to read the grammar of the question. So, you said it was arithmetic, we want the 29th term. Are you okay with that being the answer? Connor places 1 9 on the first square of the checkerboard, 3 on the next one, 9 on the next one, and so on. How much money will be placed on the 12th square of the board? Arithmetic or geometric? Geometric. Do I want the 12th term or the sum of 12 terms? I want the 12th term. And again, kids, what does this stand for? What's that 1 stand for? How much money is on the first square? What's that number? How much money is on the second square? So this number is going to be how much money is on the 12th square. It doesn't say how much money does he have altogether or how much has he put on the board total. It doesn't say that. So the 12th term, it's geometric, 1 times 3 to the 11. And again, that will come out to be a huge number. Hannah, Hitler, what is it? 147. Yeah, the unit on that would be cents, because when I set my sequence up, wasn't that cents? Oh, whoa, whoa, stop. That's not cents, that's dimes. Right? So that would be 1771470 cents. Times it by 10. Or, let's make this dollars, $17,714.70. Okay, do number 3 on your own. We just did one just like it. Do number 3. I got 503, but I did it without a calculator. Anybody match that?
That's why I got received.
Why did I use this formula?
It's arithmetic.
Because it's arithmetic. Right? Common difference is 4. Now, number 4 is a word problem, but it's kind of the same thing. She's got 2, and then 6, and then 18. On what day will she chew 1458? So we want to know which term is 1458. What's the difference? This one's geometric, so set that up for me. What's that going to look like? What's that going to look like? What am I going to write? 1458 equals 2 times, here we go. Step 1 to solve this. Divide by 2, so that's going to give me 729. Oh, shooty tooty. The exponent is the variable. This brings back nightmares of what? Logarithms. So now wait. One option is to use logarithms. But remember what you told me. if this is indeed a term of the sequence, which the problem leads me to believe it is, it doesn't ask me if it is, it kind of makes it seem like it is, then what kind of a number does n have to be?
Whole number.
A whole number, which means that 729 must be a power of 3. 729, this is going to have to be a whole number. So this must be 3 to a power. So I can figure out what that is. I know 3 to the first is 81. So 3 to the fifth would be 243. And 3 to the sixth is 729. So this number is 3 to the sixth. If it's a term, that will always have to be the case, because I have to be able to say whole number equals n minus 1, so n turns out to be a whole number. Now, if you use logarithms and you log both sides of this, you're going to get exactly the same answer, so it's perfectly okay to do that. You're going to have a calculator when you do these problems, because the numbers just get so out of whack. But if it's a term, you'll never need logarithms. You can use it if you want, but you won't have to. Does that make sense to you? You're always going to be able to make a common base, because that has to end up being a whole number. All right, here we go. Turn our page. We got tons more. Here we go. All right, Alana's resulting okay. 9 days to prepare. She gets 5 and 10 and 20. How many golf balls will she hit altogether during her 9 days of practice?
Just
All right, so the first thing we decide is it's geometric, right? And then I've heard some of you say it's a sum, it's a series. We're going to add them up. Does everybody get it, why we're adding it up? What would it be if I wanted what would the question say if I wanted the 9th term? How many does she hit on the 9th day? This says all together, so we're going to add them up. So we haven't used that formula yet today. That formula is this one. So here we go. 5 minus 5. What's my ratio? 2 to the 9. Over 1 minus 2, I'm just going to go ahead and put negative 1. All right, let's type that in. Remember when we type these in, we always hit equals before we hit divided by. Did you get 5 by 5? All right. First game of the season, Barry caught 8, then 11, and 14. If he keeps up this pattern, how many passes will Barry catch in the 14th game of the season? Okay, everybody's figured out it's arithmetic. Because we have 8, 11, 14, and so on, okay. Term or sum? Term. We want the 14th term, right? So what's the setup? We had that formula on the board several times today. What's the setup? It's arithmetic. I want a term. How's that work? 8 plus 3 times 13. There you go. That's the answer to the question. Everybody good? Francis gained 10 votes, 16, 22. How many votes will she have garnered altogether if the contest runs for 90 days? We want a sum, right? And it is what kind? Arithmetic. All right, now this is what I was talking about yesterday, because watch this. I want a sum. It's arithmetic, and we're adding up 90 of them, right? So we're going to have 90 over 2. This is my arithmetic sum formula. Now, what goes here? 10. What goes here? The last term, which, oh my gosh, we do not know. So what do I need to do? I need to find the last term. Even though it didn't ask me that question, over to the side, I'm going to have to find the 90th term. And that's what's going to go here. The 90th term is going to go in that spot. So here we go. What will that look like? The 90th term of this arithmetic sequence. 10 plus 6 times 89. All right, somebody type that in for me. What's 10 plus 6 times 89? What did you say? 544. Anybody match that?
Yeah.
Okay, so that's, what does that represent? What's that 544 represent?
Last term.
That's how many votes she got on the last day, right? So now we can crank out the answer to the question, which is how many she got all together. Okay, now number 4, I'm going to skip. I don't know how much time we have, and we already did a couple like that. Let's look at number 5.
You have like 7 minutes left, I think.
Thank you. What is the 9th term of the geometric sequence whose first term is 8 and whose second term is -4?
Adding negative, you're adding negative.
Okay, now wait a minute. There's a key word in the problem.
It's multiplied by
It's
negative 1/2.
geometric. So we're not adding anything, right? If it's geometric. Now, Dan is sort of right here. If all I did was give you 2 terms, you would have no idea if it's arithmetic or geometric. But the problem says it's geometric. So we have a ratio, how do we get from here to here? Multiplied by negative 1/2. So we want the 9th term. So that will be 8 times negative 1/2 to the 8th. And we can type that in and get the answer. The bonus down there is the last thing we have yet to learn in this section, so we're not going to talk about it today. All right, here we go. Last problem. Let's see if we can get this done. Tyler ate 2, and then 7, and then 12. How many M&Ms will he eat altogether on his vacation? It's a sum. Everybody agree? Arithmetic or geometric? It's an arithmetic sum. Well, we're going to have the same problem we had a minute ago. Because we have 2, 7, and 12. We want to add up 12 terms, right? So we know that's 12 over 2. This is my arithmetic sum formula. And then what goes in here? 2 plus what? The 12th term, which we don't know. So we'll figure out the 12th term using our arithmetic term formula, which is, how's that work? 2 plus 5 times 11. So I can do that 57. And then what do I do with the 57? Put it right here. And then I can look it out and answer the question. Oh boy. Take a look at number 6 here. This looks a little interesting. It says A sub 1 is 19 and S sub 12 is 690. think? You're gonna use a formula for every one of these problems. Which formula do you think you're gonna use? Arithmetic series, sum. You're gonna do the arithmetic series formula. Because you know that it's 690. So 690 is gonna equal what? Won't it be 12 divided by 2? Aren't you adding up 12 of them? So it'll be 12 over 2. What goes in the parentheses? The first term plus the 12th term? Isn't that what we're looking for? So we're going to solve this. So 690 equals 6 times 19 plus a sub 12. Let's see, if I divide by 6, that would give me 115. Double check my arithmetic. So a sub 12 is 96. Keep an eye on my arithmetic. That wasn't as hard as I thought it was going to be. Now it says find the common difference. Let's be smart about it. I just got to tell you, you're going to use a formula for every problem. How many formulas have a D in them? One. There's only one formula that's got a D in it. And D is what you want, right? So we're probably going to use that formula. Okay? So we're using the formula that's got the D in it. So what are you going to put where? What?
96 equals.
Exactly. You're going to put the 96 right here. That's the last term you're interested in. That's at the end of the line. What are you going to put here? 19.
Plus D,
Yeah, we don't know what D is, but what do we know about N? We know N.
11.
Well, N minus 1 is 11, yep. Because N is 12. Right? And you can work that out. Stephanie wants the low each day for 8 consecutive days. She spent 2, 6, 18. We've seen that sequence before. How much did she spend altogether? Tell me the formula you're going to use. Tell me the letters. S sub N equals A sub 1 minus A sub 1 R to the N over 1 minus R. Now why are we using that formula? Because the series is geometric and the word all together tells me I'm adding. So S sub, how many am I adding? 8. S sub 8 equals 2 minus 2 times, what's my ratio? 3 to the 8 over 1 minus 3, which will be negative 2. Now again, what's going to be the unit on that when you get this big number? It's going to be cents. So it's not as big as I thought. It's 6,560 cents, which would be $65.60. Whoa, I got a homework sheet for you. Whoa, 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 nobody escapes. Nobody escapes. Here's the homework paper, and for the first time, I'm not giving you answers. We are going to, I want you to do these totally on your own. I mean, I'm not giving the answers, you can't do like looking at my work. And I want you to, tomorrow, then we'll check these over and go over your free test and all that stuff, okay? Okay, did everybody get a homework sheet? All right.
That's what the three kids do.
Sorry about the change in plan. Yes, tomorrow morning, remember, you got stuff to make up. Tomorrow morning's it. do it tomorrow morning.
On Friday. Well, I thought I was doing last time. For the class this
Good luck with those surgeries.
Thank you. One thing after another.
Mrs. 5, Mrs. 4, good luck today.
Thank you.
Did it have to be printed off and stuff? Yeah.
Yeah.
What's the window again? Facebook.
No, I'm not gonna answer that question. I had it on the board every day, Moses. Why have you not written it down? Did you write it down somewhere?
Said I didn't write down. So I don't know, calculators. Whatever.
Moses, you've got to pay attention.
I do.
No, you don't. You don't. You say you do, but you don't.
That's okay.
No, you don't pay attention. Now, I'm not setting your X's and Y's. I told you yesterday.
I know that.
That's on you.
I know.
This one. Yeah, I got all that.
Okay, will she understand what it is? Okay, so all I have to do is get her to the X's and Y's.
I told you like anybody else in the league, you know.
I'm gonna kind of think that close or something. Is she here today?
And then one of the two of the chefs just quit. And then Dombrowski kind of quit. They hired they did no employees, it's hilarious.
Oh, shoot, that.
They're like 25%.
I want that donut.
No, you can't